Angle between lines and planes. Okay. Example 1. Determine the angle between the line r equals to 1, 2 minus 1 plus t 1 minus 1, 1 and the plane 2x minus y plus z equals to 4. Now here we have the direction number of the line, which is m equals to 1 minus 1 and 1, and we have the normal of the plane, right, which is 2 minus 1 and 1. So if we use direction of the line and the normal of the plane, then we really don't find angle between line and the plane. What we find is the angle between the line and the normal of the plane, right? The question here is to find angle between the line and the plane, okay? Let's try to understand what we have and what we need to find. Let's imagine that this is our plane, okay? And let us say that the line through the plane is going like this. Like this, correct. Now the normal to the plane is kind of like this. At this point, let's say the normal to the plane is kind of like this, okay? So coming out of the plane. So if we use normal and the line, right? Like all the normals will be kind of coming out of the plane, right? So then we actually find the angle, and let's say this point is on the plane, and let me draw a line to show you how we're trying to look into it like this. So what we need to find is the angle which the line makes with the plane. Let's say this angle is theta. This is the angle which we are interested, right? This is our line, right? That's the line. Now let me call this line as L1, okay? So line L1. Now, and this is my plane, but I know my normal, and that is my normal. Okay. Well, what I can do is I can use dot product between the direction of my line and the direction of normal to find the other angle, which is the angle between line and the normal. Let's say this angle, right? And let's say this angle is phi. In that case, the angle which the line makes with the plane will be 90 minus phi. Do you see? So we'll have theta equals to 90 minus phi. So this is something which you need to understand when we are trying to do these kinds of problems. Okay. So I hope that point is very clear, that we are really interested in finding angle between the line and the plane, which is angle theta for us. But what we know is the direction of a line and direction of the normal. And if I use dot product, that is m dot n, correct, which is magnitude of m times magnitude of n cos theta, right? So from here, let me write cos phi, because I'm using phi as an angle between them, okay? So that is what it is. Since the line and the normal is making angle phi, we can find cos phi. Once we find cos phi, then the angle between the line and the plane will be 90 minus phi. So that is another approach, right? So from here, we know cos phi is equals to m dot n. M dot n is 1 minus 1, 1 dot 2 minus 1, 1, correct? So that is a dot product, and magnitude is square root of 1 square plus 1 square plus 1 square times square root of 2 square plus, I'm not writing minus 1 whole square, it's one of the same thing, right? Plus 1 square. So this is what you get the angle phi, correct? So from here we can say dot product is 1 times 2 is 2, minus 1 gives me plus 1, and 1 times 1 is also plus 1. Divide by 1 plus 1 gives me square root of 3, and this is 4, 5 and 1, 6, square root of 6, correct? So I have here 2 plus 1 5, 2 plus 2 4 over square root of 18, right? 18 is 9 times 3, right? 9 times 2 is 18, and 9 I can take out as 3. So I got 4 over 3 square root 2 here. In any case, so let me get a calculator and find the angle phi. To find cos inverse of 4 divided by square root 18, we can say, right? So we'll do second function, cos inverse of 4 divided by square root of 18 equals to, we get 19.47. So we get phi as cos inverse of 4. I can write 4 divided by square root 18. We are using calculator, so no problems, right? And we get 19.47. Correct? And as I have shown you here, the theta is 90 minus phi, right? So the angle between them is 90 minus 19.47 degrees, right? Which is 70.52. 70.52 approximately. We say this is 70.5 degrees, right? So that is how you have to do these kinds of problems. I hope you understand. Thank you.